Ah, the seasons. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth, and there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the sun, but the Earth is spinning. And when you're on the part of the Earth that's toward the sun, it's daytime. And when you're on the part of the Earth that's away from the sun, it's nighttime. Now, the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime. And the Earth that we're on is tilted away from the sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons. Let's say that this plastic globe of science is like the Earth, and we have 2 solar panels mounted on it. Now, solar panels convert light directly into electricity. So right now, these 2 panels are making enough electricity to run these 2 little motors. Now, right now, both motors are going about the same speed. Now, notice that we have one panel in the northern half of the Earth, the northern hemisphere, and one panel in the southern half of the Earth, the southern hemisphere. They're both receiving about the same amount of light. But let's say it's summer here at Nye Laboratories in the northern half of the Earth, the northern hemisphere. That means that the Earth would be tipped toward the sun about like... Now look, the motor in the southern hemisphere is just barely moving, while the motor in the northern hemisphere is spinning like crazy. Now let's say it's 6 months later, and the Earth has gone around the sun so that its axis is tipped this way. Now look, it's reversed. The one in the south is going wild, and the one in the north is slowed way down. See, what that means is that this panel in the southern hemisphere is receiving more light, more energy from the sun than the one in the northern hemisphere. It's just like the Earth's seasons, right here with the solar panel plastic globe of science.
Using a flashlight, you can see for yourself that direct rays are concentrated on a smaller area than slanted rays. This is why direct rays produce more heat.